Hi, we're moving on to Unit 7, so we're skipping Unit 6 for this year. And Unit 7 is going to be all about statistics. Unit 8 will also be about statistics, so we'll spend the next 2 units looking at statistics. The first page of the notes should have been filled out from the PowerPoint, so if you didn't watch the PowerPoint or didn't go through the PowerPoint slides, make sure you're doing that to get these notes. There's also a bunch of fun misleading graphs in there from various news sources, so you can kind of see those as well. I think it's an important time to talk about misleading graphs just because of everything that's been going on. It's important when you get data to think about the source that it's coming from and to also analyze it a little bit to make sure that it makes sense. Okay, so make sure you're watching the PowerPoint first, and then the rest of these notes I will be doing with you. So we'll be starting with the frequency table. Okay, and a frequency table is frequency. You can think of the word frequent. It's how often something happens in a certain sample space. Okay, so it's going to be the list of outcomes in a sample space. And the number of times each outcome occurs. Okay. So down here, our sample space is all of the triangles. Maybe you surveyed some people and asked them a couple questions, then that would be your sample space. So the sample space is always changing. For example, 1, there's 3 types of triangles: equilateral, isosceles, and scalene. I want to make a frequency table for those 3 types of triangles. So all we do for the frequency table is we have the type, and then we have the frequency. Okay. So the 3 types will be equilateral. I'll just use an E for that. Isosceles and scalene. Okay. So what I would do is go through the triangles at the top, go through all these triangles, and just kind of write down, and you can tally up how many we have for each of them. So, for example, in mine, it's colored. Yours might not be, depending on your printer. The light blue ones, equilateral, those are all equilateral. So that would be triangle with all the same sides. So we have E. I'm just going to put a bunch of E's in these. And we count them all up. And we end up with 6 equilateral. Okay. Isosceles would be when 2 of the sides are the same and 1 is different. So isosceles will be, so this one right here is an isosceles. The one below it's an isosceles. And then we can kind of go through and write out which ones are all isosceleses. This one down here is 1. This one right here is 1. This looks like 1. This looks like 1. This looks like 1. If we count them up, 1, 2, 3. Hopefully you notice that these blue ones, the darker blue ones, or purple ones-ish, those are all isosceles. So that will be 11. And then all the green ones are scalene. And there are 8 of those. Okay. If I wanted to continue with this, so this is a frequency table. If I wanted to make a probability distribution, I could find the probability. So there are, if we add all these up, there's 25 triangles total. If I take 6 over 25, that will get me the 0.24. 11 over 25 would get me 0.32. 0.44. 8 over 25 will be 0.32. Okay, so this is a frequency table. If we get rid of the frequency, then and just include the probability, then it becomes a probability table. So on the homework, they'll ask you to do some probability tables. Okay, so on your own, I want you to make a frequency chart. To describe the triangles by their angles. So before you get started, we want type and the frequency. What are the 3 types of triangles when I label them by their angles? We have acute, right, and obtuse. Okay, so go ahead, label all those, and figure out the frequency for each of them. So I went ahead and labeled R, A, and O for right, acute, and obtuse, and then if we count them all up, you should have gotten 11 acute, 9 right, and 5 obtuse. Okay, and then if we wanted to add a probability part to this, we could, but I just told you to make a frequency chart, not a probability chart. All right, so let's move on to probability. We have cumulative probability. If you think of things accumulating, like snow accumulates, water accumulates, it's going to be probability over a continuous range of events. Okay. So, in the next example, we will look at the number of elderly and how often their children make contact with them. Okay, so for the first example, we want to find the probability that an elderly person living alone will have contact with his or her children more than once a week. Okay, so when we do probabilities from here on out, we're going to do a capital P, and then inside the parentheses will be whatever you're trying to find the probability of. So we have more than once a week. Okay, more than once a week does not include once a week because it's more than. So I am only looking at these 2 numbers. So we're kind of accumulating them, and I add them together to get 956. And then I can put that over the total to find the probability, which is 0.6873. Okay? So what I'd like you to do for the on your own is find the probability that it's once a week or more. For the contact. Okay? So if I'm including once a week, then I'm going to include this 236, which would get me 1,192 over the 1,391, and that probability is going to be 0.8569. Okay, so notice probabilities are always labeled between 0 and 1, so probabilities is the decimal part. Percents are different than probabilities. Those are, if we just multiply this by 100, so 85% would be this one, but the probability is 0.8569. Okay. All right, so for example 3, you will need this table on the notes, so make sure that you have it. So we are looking at rolling 2 dice, and we have the sum of the 2 dice. Okay, so we have this table. These numbers up at the top represent one die, and the numbers down the bottom represent another. So we can go ahead and fill in the table. If I roll a 1 on the first die and a 1 on the second, I have 2. If I roll a 2 on the first die and a 1 on the second, I have 3. If I roll a 3 on the first and a 1 on the second, I have 4, and then we can kind of keep going. If I roll a 1 on the first and a 2 on the second, I have 3, 4, 5, and we can just keep filling in this whole table. Okay, and then the highest number we can get obviously is 12. That would be rolling 2 6s. So total. So in total, all of these numbers, there are 36 options. Okay, so if I roll 2 dice, I have 36 options to roll. Okay, there's 36 numbers in here. So I'm going to make a probability table, and I'm going to make a graph. Okay, so the table's easy. We'll have a list of the sums along with their probabilities. So the smallest sum is 2, and then I can go through, leave some space because we'll write some fractions on the other side. So 2, 3, 4, 5, all the way down to 12. Okay. So what we need to do is, I know I have 36 total, then I look at the table, and I have 1, 2 on the table. So there's 1, 2 out of 36. And then I just divide that to get 0.028. Okay, and then I would look at the 3s and count up all of the 3s. There's 2 of them, so I would have 2 out of 36. And then I just divide those to get 0.055. And then I would look at the next one. There are 3 4s out of 36. Divide those to get 0.083. There are 4 5s out of 36. Divide those to get 0.111. I'm just rounding to 3 decimals here. There are 5 6s out of 36, which is 0.139. There are 6 7s out of 36, which is 0.167. And then 8s, 1, 2, 3, 4, there's 5 of those, so you can kind of see we start to go back down. 0.139. 9, there's 1, 2, 3, 4 of them. 0.111. 10, there is 3 of them. 0.083. 11, there's 2 of them. 0.055. And then there's 112. Oops. Which is 0.028. Okay. So that is the table. And then the graph we'll put over here. Okay. So the graph, what we want to do is we'll make a graph and label our axes. Okay, so this will be the sum of 2 dice over here, and then this will always be a probability. Okay, so you saw from some of the misleading graphs how important it was to make sure that you're labeling the axes. So we have both of these, and then we will fill in everything else. So we have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's all the sums. And then our probabilities up the side. So our probabilities go up to, let's say, about 16. So I'm going to go 0.02, 0.04, I'll go by 0.02, 0.06, 0.08, 0.10, 0.12, 0.14, and 0.16. Okay, so that'll get me all of my options. And then you can go ahead and just graph everything. So 2 would be the 0.028, so that'll be close to that. Okay, and we'll make a bar, and we're going to make them touch each other because everything goes in order. So 3 will be 0.055, so that's somewhere up in here. 4 is 0.08, so that's somewhere there. 5 is 0.11, so that's somewhere in there. 6 is 0.13, so that's somewhere in there. Okay, so 0.13 would be in there. And then we have 0.16, should go to the top. And then we slowly work our way back down for the rest of them. Okay, and then if your numbers don't line up, maybe just fix them a little bit. 11, 12. Okay, so we want everything touching just like that. So this is a nice bell curve, a nice normal distribution. We'll see later that that's very important. Okay? All right, so let's look at genes. Okay, so hopefully you've seen this, a Punnett square. Hopefully you've seen these in biology. Usually you do them for like eye color, hair color, things like that. But we are going to do it for different colored corn plants. Okay, so we are going to look at the genotype distribution and the color distribution. Okay, so the genotypes are different than the colors. There's more genotypes than the colors we get because we have this whole dominant and recessive gene thing happening. So what I want to do is I'm going to let you guys do this on your own. And I would like you to make a probability distribution. So make a graph for each of them. Okay, so the probabilities will go up the side and then the types will go on the bottom. So go ahead and try to make those graphs on your own, and then we can go over it together. Okay, so for the genotype, I did make a probability distribution just so I would know what the side axis is. So again, make sure you label them genotype and probability. There's 3 different genotypes, and then I listed the probabilities up the side. For the color, there's only 2 different colors, and then I listed the probabilities up the side. So this is 2 ways to display the same data. So we need to think, if you're a statistician and you give this information to a farmer, okay, the farmer wants to avoid raising the white corn plants. Which graph would you show them in order to help them avoid raising white corn plants? You'd probably show them this graph, right? Because you can see, based on the information, you'll get more green ones than white ones, okay? So you kind of want to think of your audience. So if you're interested in stats and you go into that, you want to think of your audience and how you want to display the data and what they want to get from the data, okay? So please reach out. That's the last example for this. Reach out if you guys have any questions, and have an excellent day.